Hi there. It's me. It's me, Scott. Let's just go. I think I hit the wrong button. This button? This button? Here we are. Hi. Switch from wallpaper. I don't have much to say today. I just want to start. I just want to do the thing. I don't know. I think I remember how to calculate normals like this. I don't think it's actually hard. I think it's just a cross product, but I could be totally wrong. And it will be a little hard to just like look at it and know, but it's okay. Let's try to figure it out. Cool building. So unpleasant to clean. Oh, I forgot to do the thing. Wait, the thing. I forgot it. Okay, I did that thing. Where are we here? Austria. Anyway, yeah, so I have an idea of how I think you're supposed to do this. So first we'll start with how in my mind I think, oh, that's pretty cool. How in my mind I think it works, and then probably will fail horribly. Let's just go with this. And, you know, then maybe we'll have to actually look it up. But, what are we looking at here? That was me not remembering how UVs work in Three.js, I think. Okay, so we'll have a trillion things open still. It's a good sign. I think we want this. I don't want any of these things at the moment. We're feeling pretty good about our Cartesian conversion and so on and so forth. But what we don't have, what do we want to start with? Let's not do our little sphere randomize. At some point we should actually clean up this document or whatever. So we have no normals at all, I think. Or we do have normals, they're just totally incorrect. Like our normals are just not a thing that makes sense. So actually that's interesting. How can we like basically our normals are when we're in this sphere mode, they're just, you know, the vertex normalized basically. There's nothing fancy about that. Excuse me. So that would be like after we do this, excuse me. Starting streams with stuff in my eyeballs lately. So, yeah, what do we do? We want, like this, if we normalize this, that would be our normals. So that's fine, but how do we set that? Like normal, I don't know I don't think we can edit the things that come straight into us. We just want to view it. So I guess it's just, let's just do this and figure it out. But it's normalize new position, right? And of course I've done something wrong here because that's a vec4 XYZ. I think normals are vec3s. Okay, so we've got our sphere. So if we wanted to, we just say color.xyz equals normal.xyz. And this is just us visualizing the normals. So that immediately kind of doesn't look right. At least on just a sphere. Because it would be the new position, but it would be before we did any stuff to it. Like it'd be before we did our world position. So you could maybe make the case that it should be, but our world position and our, we're not translated at all, and we're not rotating on the CPU side, so that should be the same. This doesn't look quite right to me. I guess an easy comparison we could make, just so I have a point of reference, is I don't even know what I have in this project. But let's make a quick unlit URP shader. That's a plane. Okay. This project's a mess as well, but we're gonna clean this up. This project has a future. But just get a, just so I have a point of comparison, because that doesn't, it's not looking the way that I think it should look. Okay, we got this fun ball. And this is, oops. Our normal vector, an object space, oops. Oh no, I got lost. Where am I? Get out of here. Kyle! Lerp. Lerp is short for linear interpolation. And it really just means that I have like a point A and a point B, and based on an interpolant, which is just almost like a dial that you turn from 0 to 1, you can say something goes point A to point B. So it's used, it's a concept that's used constantly in, well, in a lot of things really, but in particular like graphics and animation, because it's a way to blend things together. So if you have two colors, for example, you had like whatever, red and blue, and you could like lerp 50% between them and be green, for example. I think that's right. Anyway, you get the point. Or if you have like, I have a starting point over here and I have a starting point over here, and I animate from 0 to 1, you'll see the thing animate along. The interpolation is linear, but you don't necessarily have to, the animation doesn't have to be linear. Like you could run, your interpolation could be along a different curve. That's a little more complicated, but the general idea is it's just an ability to move from point A to point B. So the previous animation that I had set up for this, how did I get so lost, was really just like pick one shape and pick another shape, and then just sort of transform between those two shapes over time. How are you, Kyle? That's wrong. 8080? I got lost. So I'm a little confused here as far as like what we're getting for our normals. And it's not, the confusion is probably just that I'm not thinking of something, which is how this normally goes. Like I'm just forgetting something, or am I viewing just the back of it? Is that the issue? Is it backwards and upside down? Is there some point I could find that would make this look like this? Like I don't remember. If that's the normal vector, I feel like I want the normal vector of the object, which would just be like this. Makes a bit more sense to me, although it kind of looks upside down. But maybe this is not fully incorrect. Like I can see the green back there. A normal just is kind of like a direction a thing is pointing. And so our big issue is right now we have that idea. Like we have the idea of where something should be pointing, just because when you're a sphere, your normal is just wherever you are on the sphere, that direction from the center of you. Which in this case, because I am centered, unless I'm just not thinking of something. There could be something that I'm just not considering. Because I don't think we're actually using this at all, right? I mean, the actual position as described by the mesh, I don't think is a thing. Good grief. Is a thing we're even concerned with. What we are concerned with so that's just to calculate this. I'm going to remove, let's turn off this animation for the moment, just to make sure that it's not doing anything weird. So our new position is just our XYZ and just the, essentially that with a radius of 1. So new position XYZ. We don't mess with that anywhere in here, so we're just saying that color. So maybe that's right. It just doesn't, in my mind it looks different. In my mind it looks more like this. So what are we doing wrong? Like, how are we losing, yeah, this is what the normals of a sphere look like in my brain. So one, I don't know why it's different in Unity, and I don't know why it's different. And it seems like correct-ish, right? Like it seems correct in terms of being, yeah, it's blue over here, cyan up here, magenta over here, like, and white up here. It's just the way, I don't know. Something about it doesn't feel quite right. I mean, if I don't normalize, that's a big problem, of course. And this XYZ, kind of want to, if we do this, we should have a unit sphere. But even that is funny. And it doesn't seem like it's a precision thing. Or maybe it is? What am I missing here? I mean, I feel like if it was a precision thing, we'd be in worse shape. Good grief. You... Just add this stuff, just because I'm not even sure that's exactly the right thing to do. Okay, does not seem to be a precision issue. So what's my problem? I'm getting an XYZ. It's putting things in space where I expect. So why do the normals not look the way I expect? Is there some other thing about normals that I'm not... that I'm just not thinking of? I would prefer you didn't animate. Transformed normal is the normal matrix. What's the normal matrix? Times the normal matrix. Normal matrix, what does that mean? Geometry normals on object space, transform the world space, etc. etc. Yeah, but I'm not trying to transform my normals. Is that true? Life is yours. How's it going? What am I forgetting here? I feel like I don't need to do that. Like, I'm doing my own normals. I shouldn't be. I'm not transforming them to some other space. I feel like. What thing am I forgetting? All we're doing out here is drawing the color, and all we're doing with the color is setting. Or if it's just like a, nah. Wish you aren't rotating. It's really not helping me at all. Oh, this guy. This guy's he knows what he's doing. Normal. Yeah, nothing. Well, I don't understand what my problem is, and I don't understand why the results in Unity. There's a couple things that I understand. I have a laundry list of things that I am not currently understanding. This is what I would expect. So, is there something weird about color? Is there something about color that I'm... I guess it really is normal. Normal. I'm not sure if I can do this stuff. I guess it has to be like V normal or something. I don't actually like that at all. That's just coming from... Windows 95 screensaver? Is that what we're going for here? That rotating block? I like the pipes. The Windows 95 pipes. It's a good screensaver. Varying vec3 normal. I feel like I've broken something. V normal, right? And then let's visualize V normal. And great. Because that's supposed to be vec4 with 1 alpha. Like, to me, it just doesn't look normalized. But that's what it would look like unnormalized. It doesn't look normalized enough. So what am I missing here? Each of these vertices. I wish I had an easy way to draw that in Three.js and just like actually visualize the normals. It'd be easier here. That's funny. Where are you? You positioned weirdly or something? Well, I guess, okay, maybe a couple things. I think actually the way I was thinking of it is not correct. Still almost feels like we're looking at it from, I don't even know. Not straight ahead. Is the camera elevated or something? Oh yeah, our camera's in a crazy place. Oh, right. Do 0 here, -10 here. Well, wait, we weren't even looking through the camera, so never mind. Why does it look so bad? Okay, I mean, this is not... That's funny. Why does it look so crazy? Is it the post-processing? What would be... Sounds like quite feel right. I'm not really sure what I'm missing. The straight up object normals. I mean, maybe it is right. I guess the thing that's really thrown me off is the way the gradation is working. This doesn't seem right. So I'd feel a little better to see it. See it in Unity, like just to have confirmation that like, hey, this is what it should look like. Like the idea of blue transitioning, you know, whatever, 3/4 of the way through to magenta, we kind of have, it's just that this transition. Actually, okay. Now that I say that, maybe an important thing to do while we do this is not mess with we're messing with the colors. So let's turn off the composer and just turn on regular old rendering and see if we feel a little better about that. Okay, that looks better. That's all. I think that's all it was. So this is looking more, it's inverted somehow, which I don't exactly understand. But I mean, it's not even just like rotated, it's like inside out. But I think, I can't remember if like WebGL is Z forward and Unity is Z backwards or something like that. So actually these normals look fine. It was false alarm. Okay, so now the thing we want to do though is the problem we have currently is as we do this, our normals are not correct. Like this is not, we're still showing the normals of a sphere, even though we are no longer drawing a sphere. And like, it kind of works for, I mean, we can kind of use it to get some kind of variation. But it's not physically accurate. I mean, not that any of this is physically accurate. It's just not, it's like, we have a sphere and we're stretching it to be a different shape, but light still hits it like it's a sphere, if that description makes sense. So the thing we want to do, and this is going to be a little tricky, so I gotta think about it a little bit. It's not going to be crazy tricky, but basically we have to take, what I think we have to do is, say we're trying to figure out the normal for this point right here in the middle. We need to take that point, sample it, figure out exactly where we are based on our fun formula. Then we also need to go a little bit ahead and maybe a little bit up, and then also sample those. And if we do that, we have a vector going, you know, we have like a vector along this axis, and we have a vector along this axis. I don't mean like X, Y, and Cartesian. I mean like along phi and theta on the surface of the sphere. We have two vectors pointing along those two, I don't know what to call that, surface axes. Really? Can you find the book? What book was it? If we have those two vectors along the surface in two directions, let's call it north and east. Like we have a north vector if you're standing on this globe and an east vector standing on this globe. And based on that, you want a vector pointing straight up. I think we want cross product. Alpha finds something strange. Whoa. Hey, look! It's my blob. My blob was in a Sesame Street book. Sesame Station? Station? Alpha finds something strange. Is there an English version of this book, or is this a... Oops. So a Norway only. Okay, this looks like a kind of a different book. Alpha Daddy Bear. Okay, I think this is a Oh, interesting. So it's like Sesame Street, but they're at a train station? Well, that's cute. That's a low rent looking Muppet, I gotta say, though. Oh, these Norse knockoffs you have. Look at this guy. This Muppet looks kind of like you. If he was a little more purple. Got like a slight pinkish color here, but... Wow, how long did they do this show? Quite a young lady to not as young a lady. And our little train, constant runny nose, gross. Great. Well, this is my Alpha Find Something Strange tribute art. It's fan art. Okay, so anyway, what we need to do is we want some method we can call that will give us this. I don't know what to call it. It's called evaluate. And basically we'll take an eVec2 that is our UV. No, eVec, I almost wrote JavaScript for a second. Position is going to be eVec 3, I guess, for our dot product, and we'll just add the W when we need to. It's going to be something like this, and inside here is where we're going to have to do this stuff, basically. Oh, the animation part gets annoying, though. But I think it's basically going to be... Find theta. Here's where we do all our business. Here's where we calculate our... Okay. So we get find theta based on our UVs. We do our magic. We have our float XYZ. I'm gonna ignore time for the minute because maybe I'll just decide to do that a different way. But for the moment, let's ignore that, and then we're gonna return that position we just calculated, right? So that means we can ditch. Wait, can we? Did I paste that? Okay. We can ditch kind of all this. And just to get it working, let's do eval UV. I broke it. Unsurprising. Evaluate. What did I break? Who can say? Who can say? radius. You're not void. Vec3. What are you doing over here? Oh my gosh. Oops. It's not in the UVs for now. Maybe we'll want that later, but at the moment. Oh boy. Mars undeclared. Oh, am I still using the radius down here somewhere? I am. I wonder what the radius is. That's a little annoying. This is a bad way to do this, but I'm gonna do it anyway. Okay, I've fully broken everything, so that's good. Great. What did I break? That's the new position. Let's ignore this. That was a different rotation I was trying. That's our world position, which really is the same because we're not rotating. That's to get our for now. Did I accidentally delete something down here and like render it black or something? Should have paid more attention to this. Maybe done it in fewer steps, but we do have the color. We have the color. Out position, which was the new position. We evaluate. That's just based on UVs. We feed UV in. We return to the Vec3. Oh, well, sure. That was silly. We don't need this. Okay. So we're back to being functional. Sort of. Can I see this on YouTube? Can I see some Sesame Station or whatever it's called? Can you tell me how to get... I feel kind of faint and weird today. I don't know why. If I pass out on stream, call the police. Don't call the police. This is America. Never call the police. YouTube.com Sesam Station. The intro. Am I gonna get a...
For å se at stakkars og tidemann blir helt forvirra I hjertet sitt.
Is that you? Look at that purple sweater. Is that you when you were little? Hand cooking. You have the runny nose? Gross. Why does this kid have no shirt on? What kind of train is this? Kids love it. Look at the beautiful blonde children. Okay, give me that 1 hour episode. Not even born. It's kind of sinister. The music has like a little bit of a Hollow the Mountain King vibe at the beginning. Dun, 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 dun. What is going on?
Bøker kan vel du også skrive en?
Hva? Mener du? En bok til, og så blir det 10 bøker.
Dagen ute, du. Du skal være stått opp for lenge siden nå, vet du. Max har fiskebok.
The monsters not want to get out of bed.
Mange vogner, det.
Where's the nice lady?
Det
There she
var
is.
en gang en togstasjon. Og inne på stasjonen var det en skog.
Shunen.
Det var en ganske skummel skog. Nesten var slettis ikke noen bur. Ja,
Berømt eller noe sånt, siden jeg tar så mye bilder.
Om hun er berømt, jeg.
men vet du hvordan det skal
Oh,
være?
sta-
Jeg
stasjonen.
skal skrive på vanlig hvitt papir.
Så mange måter å skrive bok på, vet du.
It's a great show.
Ja.
What is that weird British show with the little pillow dog? The one that I think Comfrey is based on from Quentin. No, what is that show? There's like a pillow creature. Maybe it wasn't. Maybe it wasn't British. Oh, look at these BBC. Look at these BBC nightmares. Okay, wait. Skomaker gata toflus. What? Wait, what is this guy? Is Skomaker? Is that a shoemaker? Is this a shoe? What is this? Okay, and his friend is like a little... Is it a horseshoe? Get it? Why is this guy so creepy? He looks like, a living talking shoe. This guy looks like the Dan Aykroyd character from Nothing But Trouble. Dan Aykroyd, Nothing But Trouble. Right? Like, basically... Same energy. Same vibes. His nose was yeah. That's what his nose was, and that was just in the movie, and somehow that was acceptable. And am I gonna get in trouble on Twitch now? From eats that hot dog. Maybe that's photoshopped. I don't know. That's how I remember it. Did you love this show when you were a kid? Okay. I feel like I'm gonna be banned from Twitch now because I just looked at that. Wait, who has that shoemaker is named Scott Garner? What a shock. Okay, what are we trying to do? We're trying to get some normals. And how are we going to do that? So we have to evaluate okay, I'm going to think about this a little bit. We need like vec3 current position, and that's going to be the evaluate UVs, right? Easy. Vec3, I don't know what to call this, like north position, and this will be a new vec2, and it's going to have U and v plus what? I don't know. Some percentage doesn't really matter, I guess. You'd really want it to be like, let's say 5% north. I'm probably thinking about this incorrectly, but oh well. I mean, in terms of the naming, vec2 u plus 0.1 because we're going the full equator. So I think to be proportional, we'd want it. I don't know. Maybe that's not even relevant. Anyway, so we have all this, and then basically, so hopefully this still works. Oh, what did I break? Probably something dumb. Probably something dumb. Oh. I don't even know what I was thinking. UVX, UVY, UVX, UVY. Wait, I didn't even look. What happened? I wasn't paying attention. What are we looking at here? What did I click? This? Oh, it's the one about the Trump. Some tweet about all of Trump's friends looking like they're from Nothing But Trouble. How did I find that image? What did I click on? I don't even know. Pretty weird movie. I mean, sorry. I just didn't register it. Oh, it was? It was, the tweet was? Well, now we're never gonna find it. Sorry. It's pretty gross. I can't go back in my history. Who knows what we'll find? Something embarrassing? Well, but I did the whatever, Command-Shift-T to open closed windows, so. But maybe you're right. I guess if it is in this window. But I feel like I closed the window and then reopened it again, so who knows? Who knows now? So gross. Are you serious? Okay, what am I actually looking for? What am I looking for? But like in just some image on the screen? Oh, this. I see. I thought you meant like a screenshot from Twitter. I understand now. Okay. I understand now. Sorry, I thought it was like a literal Twitter screenshot. Got it. Who is this guy? Who's this pretender to the throne? He just took my name and stuck in a bunch of extra letters. Thinks I wouldn't fall for that? Got a lot of followers. Very famous. Got a cool podcast. Oh boy. What is a tiny puppet? Okay, I can't deal with Scott Gear anymore. Okay, so I think what we want to do, and I'm probably wrong, but here's what I think. Why do I feel so weird today? Something like this. Okay, we got our color again. Should I get that pizza today? I should stop eating out so much because I don't really have any income right now, right this minute. I'm waiting for some jobs to start up. I've kind of felt weird for a few days. Maybe I need to, like... I don't know. I haven't gotten outside enough, maybe? I feel kind of weird. Whoa. It is Saturday? It is Saturday, it's true. Are we going to hike tomorrow? Okay, so here's our like actual normals. Now, here's where I'm just going to start making up math. Are you ready for this? You're going to love it. We're going to say that our normal is the cross product of normalize north position minus current position and cross that with normalize east position minus current position. Does that look like math? Kind of looks like math. That doesn't mean it is. One parenthesis short here. I don't know. What's funny is that kind of looks like this. Okay, but it doesn't seem... kind of feels like we're in the ballpark, right? Like things that are sort of aimed down are green and things that are sort of aimed up are red. Almost like you can imagine it's like there's a green light down facing up. There's a red light facing up from the bottom, and then there's a blue light facing along. Sorry, red light should be facing... I think I said that wrong. You would think that the red light would be lateral, so things on the left should be lit by red. Things facing left. This doesn't quite look right, actually. Green would be RG. That would be the y-axis. So it would make sense that things facing down... And then you would think that forward to back would be blue. Like things facing away from us would be blue, but things facing towards us would go towards black. I guess that's happening. It's hard to say because, you know, those are things facing away from us. In fact, you almost would not expect to see any blue at all, but maybe we do just see this little fringy transition. Well, there's no light source. It's just kind of the idea that we're dealing... Who's sending me a bunch of emails? I don't want any of these emails. Not a single one of them. Here's Oculus telling me... that somebody... well, whatever. Okay, that's fine. Okay, so... Yeah, there's no lights. It's me just calculating the normals, but it's almost like there's a light. It's like telling me things that are facing down and Y versus things that are facing up and Y. So that appears to be working. And then X would be things that are facing left instead of right, basically. So it kind of makes sense. And then blue would be, I think, where Z is going the other way. So the thing that's complicated about this, of course, is that we're really naturally we're going to get some negative values here. So could we try to cheat that out? We could square it to cheat it out, or we could plus 1 divided by 2. Oops. Oh no. Okay. Wait, what just happened? Okay. Ugh, caps lock. Okay. Normal plus 1 divided by 2. I don't know if that's really going to fix it. Okay, that was wrong. What do we do wrong? Can I not just add 1? Dang it. Okay, what's wrong now? Now I can't tell what I broke because I was accidentally in Okay. So that helps us. Okay, that makes a little more sense. So we're just pulling it yeah, this looks a bit more like I would expect. Looks kind of cool. Oh, we could add heat to this. Okay, here's the thing. This kind of looks right, but it's so hard to say. There's no light. There's no light. But what I could do, what I'm aiming towards anyway, is the Fresnel, and I think the Fresnel will tell us what's going on. I think. So in here, we now would want a dot product between, instead of this, how did I apply the Fresnel before? I don't think it's gonna work. Anyway, this would be like our current idea of Fresnel, which is wrong. Gonna be an easier way to do this, but good enough. Well, but I don't want to manipulate. I don't want to manipulate the normals. I want the normals to be exactly, you know, I want them to be the thing they are. Let's invert the Fresnel, and then we should get. Oops. this is the thing. The whole reason I'm calculating normals is to try to figure this out. So let's just see if this looks the way we want. So this would be, this is our Fresnel that we're currently using, which is not correct, right? It's not actually, it's correct for a sphere. Things are more visible as they are like as they face away from the camera, it gets white. The more a vertex is facing towards us, it gets black. With it is the way I have it here, which is the current effect we're using, and it's kind of okay. Like, it's kind of okay as just a way to get an interesting glowy thing, but it's not the best. So instead, we want to not use this. I think we just want to use our newly calculated normal. It's weirdly a little bit off. Why is it off? Like, even here. What? So we got our world position. We don't really need this. Camera position minus. So that's with the camera position, but the camera's position. I guess I do want that. That would be the camera position minus. Does this really matter? Does this actually matter? Oops. It would if I was rotating it, but I'm not. Why is that a little bit off? That's pretty weird, right? We have the north position, we have the current position, east position. Or is our sampling... Let's make our sampling consistent, just to make sure that's not doing something weird. And it might actually be wrong to... How funny. Maybe I need to be more granular. Okay, so it just wasn't... I wasn't accurate. I wasn't being very accurate, I guess. So you'd really even kind of expect this one to be 05, probably. Whoa, okay. So how do we feel about these? Pretty hard to tell because they're so crazy looking, but it kind of looks not incorrect, I guess is one way to put it. We really should add the orbit camera, probably. Also, we do want this to the world position. We do want that if we're going to try to rotate it. So let's try to add the rotation, but let's just add it here. I think my math's going to be wrong. If we do this, yes. The reason for that being... That's the world position is the model matrix times the new position. And then we get a vector to the eye, and then we're looking between the eye and the world position. Well, that's a little confusing because that actually seems like that should be correct for this. But our problem here is our this normal is not accounting for that rotation. Ugh, I kind of don't want to make it account for it. But maybe we can just add time back. Just pass time in here when we eval. Kind of a weird way to do this. Okay. So again, as things are like totally facing the camera, they should be black. I am squaring this so the fall off is not exactly what you'd expect. Like you would really expect it to be. Wait, that was the wrong one. This one. But I'm probably on the back of it. So let's renormalize this 0 to 1. So this would be Fresnel equals Fresnel plus 1.0 divided by 2. Because normally a dot product is -1 to 1, and this will make it, yeah. I think I like the increased power, so we may add that back anyway, but. Okay, so this is getting us back into Ghostly Land. Looks like there's still some not good stuff happening at the poles. Don't really have an explanation for. I mean, it has kind of felt like our math is breaking down at the poles anyway. You know, like something's going on there where the... Maybe? I mean, I don't think I'd need to... This will never be a value that is different than 0, 1, so I wouldn't need to clamp there. Maybe there's something up here. Well, I am modding, so that's effectively clamping here. It's wrapping, if not clamping. I don't know. There's something... I don't know. At least with the ATAN 2, I didn't think it would be a problem with just sine and cosine, but like with ATAN 2, there were issues under certain circumstances where you get really weird numbers. In fact, I wondered if these were all integers, if we'd still have the artifacts up there. We would. Yeah, there's just something not happy. Which is too bad, because overall this is looking pretty cool, I would say. Right? Like this is getting us back to the original thing that we liked. So let's try this, because I know this is what Life is Yours wants, is going to be alpha. So what I'm thinking is if we could set color.a equal to our Fresnel. Then we have to like support alpha, so I have to remember how to do that. So how do you do that in Three.js? Purple. It could be purple. It's true. We could do that. I just can't remember like the blend function stuff, how Three.js wants that done. Do we do it on the material, or can we just do it in the shader material blending? Because we are, let's make sure we're actually sending that. Colors of vec4. All we're doing is showing the color. Color.a should be our Purnell. Pretty. Maybe it's not specified in the shader. It's the material, so it's a bit different than Unity. So when we specify this material and we give it this stuff, we could presumably do this. Oops. Let's go back to squaring our Purnell. Okay. So we're getting back to the realm of the thing we liked in the old days. I don't want back faces. Maybe we do want depth test on. I just don't remember really the best way to do this stuff. And oh, actually, the thing would be not to square it. That's tricky. How could you do this and still leave the? Because you could still leave the back black, basically. In fact, now we're looking at the black, so we want to. I guess just invert the Purnell. Is that true? How would you do this? Not like that, apparently. I think I actually am. I think it's just so. Great. It was not really the way to do it. Okay, I really had to actually think about this with my brain to get this to do the thing that I want, but I feel like we're on the right track, maybe. Yeah. I think this is my preferred so far. So far. -1 times. Because no reason. You're probably right that that would be effectively the same. I don't have a good answer. Sometimes I just do things, you know? So I think actually one of the main things, though, is that we weren't 100% previously. We were more like... we were just kind of dimming, but not going fully black. We definitely still have some artifacts in here that are not so hot. Like any geometry issues. And I just don't intuitively know at a glance what's going to solve those. The weird pull in the middle is a really weird problem. Like there's something... If I had to guess, that's us going back to polar, but like the values where phi and theta are 0 or something like that. Like I couldn't tell you the exact thing going on. Curious though if it's related to this. And maybe we actually don't want that. Okay, that seems like it got rid of that pole. Because I think actually what was happening, that would make sense. Like it was a mistake for phi, for sure. Because it was wrapping it down, so when it thought it should be at the top, it was connecting to the bottom. So that was a mistake. Theta, I think you could still make the case that you want to wrap, but phi doesn't wrap, theta does. So I guess what I would say is maybe this is right. Because it's kind of a weird thing to think about when you're dealing with polar coordinates. Theta is going all the way around, like around the equator of the Earth, basically. A full 360 degrees or a full 2 pi radians to wrap around this way. But to wrap around this way, you don't wrap all the way around or you'd be overlapping. You only go 180 degrees or pi. So in that case, the wrap was actually a mistake. So, I mean, a lot of this is going to be magic numbers, and probably the right answer is just to expose all this in the little GUI, just to get some magic from the magic numbers. But it makes me feel like the normals are not terrible. So I am actually... Life is yours. Can you do me a favor? Can you please pretend to be proud of me for remembering or like understanding how to calculate normals on the fly? I feel like I want to pat myself on the back. Good job, me. I mean, it literally was just the cross product, but you know, sometimes you gotta, if you don't do something for a while, you forget what a cross product is. And I use personally, I use dot product all the time, but cross product, I just don't use as much. Okay, let's turn on our fancy effects and just see how it looks. We're definitely not where we want to be, but we are closer than we were previously. Oh my gosh, do you want to talk about dot product and cross product? Let's talk about it. Okay, I feel like we're getting somewhere actually. Like, I feel like we're not too crazy far off from our ridiculous 4 million particle simulation. No, cross product and dot product are very, very different things. You use them sometimes in similar contexts to accomplish goals. Like for this, I'm using both. I'm using the cross product to figure out a normal, and then I'm using the dot product to figure out that normal's relationship to the camera. How should I explain it? I feel like we've tried this before. Like early on, I would try to do drawings on stream to explain things, and then I didn't like it. Or I just didn't have a way that I felt great about it. On a Mac, it would be easy, because I could just plug in my iPad and use it as to draw on. That's partially true. Yeah. It's a little more complicated than that, but that's not bad. And I mean, the way I'm going to explain it is not going to be hyper accurate anyway. But if I have, let's just say that I'm me, Scott, and I have, you know, my eyeball, it's very thick. Say I have a sphere. Here's my terrible sphere. Sphere. Terrible sphere. I should have used a tool that automatically does this. And then my eyeball is here. And my eyeball, pretend the way my eyeball works is like I'm sending out rays, which is how I think in antiquity some people thought eyeballs worked. That something came out of your eyes. But I'm like sending out these lines, and all a dot product is in this context, and of course there's a million other contexts you would use it, but in this context is like if I'm looking at this thing straight ahead of me, the dot product kind of tells me like the facingness of any point on this surface in relationship to my eye. So if it's right here and it's right in the front, you're correct. The dot product is 1. Like it means like you're very facing, it is very facing you. However, if I'm looking over here, at the very edge of this, I literally can't see it. Like it's smaller and smaller and smaller and smaller. So maybe, you know, up here it's like 0.99 or sorry, 0.001 or something like that. But by the time we get here, it's 0. And so even just in that way, it's a very convenient way to know if two things are facing each other. And that can be your eyeball and a surface. It can be a light if you're calculating lighting. It can be like two objects relation in space, whatever. Use it all the time. Use it all the time in 3D graphics just to know like the facingness of a thing. Sometimes I even use it if it's like, you know, you're doing something in 3D and you want something to respond to like if you're looking at it or not. You know, say you're making a VR thing and you want to respond, have a thing respond when you look at it, but just in the proximity, not necessarily from a specific raycast where you're like raycasting, trying to hit things. You can just know like, oh, the dot product is within 0.5 and 0.5, which means it's kind of like in this vision cone. And then back here, if a thing is totally facing away from me, it's -1. And so often you see this drawn. Well, basically, if you drew this, of course, it would be white here, and then it would go down to 0 at the edges. I was doing the inverse of that, but that's what we saw initially. So when I very first did this, the thing we were seeing was it was white in the middle and dark on the edges. Then I'm doing 1 minus it, so it's just giving me the inverted value, and I'm squaring it also. So instead of going 1 to 0, -1, since I'm squaring it, it's going 1 to 0 to 1. So the back is essentially lit 2. And then squaring is just a really easy way to get something back in a 0-1 range. Oh, the formula for dot? It's not very complicated, but in most graphics packages will just provide it for you. Like OpenGL has it, Unity has it. I think even JavaScript math dot. I can't remember if even the math, it's in math.js. I can't remember if there's just like, JavaScript may not have it. The formula for dot is, let's see. It's the absolute, let's see, I have to remind myself before I say this, because I almost never actually have to calculate it. Math is fun. Dot product. A dot B. So it's the absolute value. I'm sorry, it's the length. This is like the normalized. It's the length, the magnitude of A, which was like a distance function. You could use dist. I guess length in OpenGL. Times the magnitude, the length. Yeah, it says right there. Of B times the cosine of the angle between the two, if you wanted to write your own dot function. And then to do this, you also need to be able to figure out the angle, and you need to figure out the magnitude. In OpenGL, you would just use length here. I think in Unity it might be called mag or magnitude. I think processing calls it mag or magnitude. But anyway, most of the case, I couldn't even have told you this off the top of my head. This is the way actually that I'm more familiar with. Is you multiply the matching components of your vectors and then add them together. So this is the way that I'm maybe more familiar with. And to add z, you just have z in there as well. I think it's just plus a z. Were you using a physics library or you were just writing it? I mean, so that's another place it's used for impacts. I know I explained this really horribly. It just was not in my head because, like I said, I just used the version that is available. And then now that I think about it, I think this is actually, the last time I had to write a dot product was probably like this, like, which was probably in JavaScript. And I was probably just trying to do something in like raw JavaScript, because anytime you use a library that is a graphics library, I feel like there's always a dot product. Anyway, I explained the math poorly, but you can see it right here. It's not very complicated. And it's just going to give you a value of facingness, where 1 means a thing is facing you, 0 means a thing is perpendicular to you, and -1 means a thing is facing away from you. I'm sure there's like, that's probably a terrible mathematical explanation, but that's what it's used for in computer graphics all the time. Binary, how's it going? Yeah, I mean, it's one of those things, I mean, honestly, it's one of those things that this is irrelevant to me, because all I care is a thing facing me or is a thing facing away from me? And I use that all the time. I use it in, yeah, like all the time. It's just a super common thing, but I never write it, or almost never. I can't even remember the last time I wrote it. Cross product I use less, but cross product, at least the way I think of cross product, is you know, so what I'm doing with cross product, let's pretend the globe is unwrapped and it's like this, you know, like a map that's spread out, and I know where I am, right? And I can like cheat and sort of look a little bit up here and a little bit up here. So that's what I called these, the north sample or whatever I called it, north position and east position. And by looking ahead to where this point and this point is, it means I can figure out a vector that goes this way and a vector that goes this way, right? So that is here, this north position minus current position, east position minus current position. And if you have that, you have some understanding of you have some understanding of a plane, basically. You in this case, I know what's going on along the phi direction and the theta direction, or if it's easier to think about in 2D, along x and y, and I want to know where z is, but I want to know it no matter where this piece of paper is in space. So if I know, this is the way I think about it, like this, is like, if I know what's going on this direction over here, and I know what's going on in this direction over here, and I want to figure out what this direction is, if we're talking about being planar, this direction, this guy, is the cross product. It's the vector that is perpendicular to both of these. So that is, it's basically if I have a surface that I have created in whatever way, and I want to know something that is perpendicular to that surface. Let's see how bad my explanation was. Cross product. Okay, it's a vector that is at right angles to both. So it's perpendicular to that surface is how I would put it. And so the relationship of two, if you just have two vectors, two directions that you can look, and you know where they exist relative to where you are, which I do, because that's what that eval function does, I can figure out where to point. And that means on the sphere, it's really easy, because it's like, oh, it's curved up here and it's curved up here. And so I'm going to point somewhere that's like, there's going to be a little plane made there, and I'm going to point in the direction of that plane, and it's going to be very easy. Once we start to distort this and make it crazy, we have to have some situational awareness. I don't know how else to put it. You like have to be aware of what is going on the rest of the mesh to be able to do the thing we want to do, and that's what cross product is doing for us. Well, yeah, so there's so many things that are like have these rules. Like quaternions, I think, have like right-handed rule and the left-handed rule. I forget that all the time. I forget it all the time. Or actually, I think there's a lot of contexts where that comes up. Right-handed and left-handed. I mean, I will very freely, willingly admit that I look at most of this stuff, you know, in most things, I guess, really, there's like theory and there's practice. And I'm almost always more focused on practice when I'm making things because I'm making a thing. And so I totally admit that I just forget the underlying math because I don't use it. Like if somebody asked me to, without thinking about it, asked me to write something that used a cross product or a dot product, I would not have much of a problem doing that. That would be fine. If they asked me to write the implementation of a dot product or a cross product, I would either have to think super hard about it or I just wouldn't be able to do it, just because it's one of those things that I never need to do that. I use them all the time. I don't need to write them ever. Anyway, these are really powerful when used together because, you know, again, the whole thing I'm doing with the dot product is trying to tell if something is facing me or not. The issue is we don't have an understanding of that based on just the raw geometry of this. How can I know if a thing is facing me or not? So that's why I need the normals to be calculated, and the cross product is what gives me the normals. So very often, I would say I use dot product all the time, and when I use cross product, it is either in the service of building geometry, like if I'm trying to like build, if I have like some spline or something or whatever, and I'm trying to build a mesh that goes along it, you use it in those contexts. But most of the time I'm probably using it in service to then be used by the dot product. So that ends today's terrible math lesson. No, it's not absolute value. It's magnitude. So that's why it's a little confusing. That's what I thought when I first saw it and said absolute value. I think that is not, when you're talking about vectors and you have those little doodads on the side, I think that is referring to the magnitude, which is just like, yeah. So vector, you know, you have the little hat on the top that's going to say it's a vector, and then the bars on the side. And that, I mean, you know, obviously it just confused me a second ago when I looked at it and I initially read it as absolute value because I just forgot. But and different packages call those different things, which is a little bit weird. And it's not that hard to calculate. I mean, it's basically this. It's a relationship of the two, again, like the two components from the two vectors, or just, you know, you can continue on if you have more dimensions. But I'm also terrible at mathematical notation. Like, it really takes me a while to navigate this. It's way easier for me to read code. Eigenvectors. I haven't thought about eigenvectors since... Oh, that's not true. I guess when I was doing really early... when I was doing machine learning stuff in grad school 10 years ago. Almost 10 years ago. I think that was what we were doing in our support vector machines, maybe? I can't even remember. That is not a thing I could intuitively explain at all. It's not even in here. Well, I mean, I don't know. Would I call that? I wouldn't call it the same thing. I guess they're conceptually related, but absolute value, you know, I normally think of as, well, right. In that context, I don't know, maybe I'm wrong, but conceptually for me, when I think of absolute value, I think of like the abs function, which is just get rid of the sign. You know, that's what I associate. What is that not true? Like the absolute value, isn't that also lines on the side, or is it two lines on both sides? Is that what I'm not remembering? I just can't remember the notation. Like, what's the notation for absolute value? Yeah, it is just lines on the side. So this is confusing. Like, absolute value of an integer just means you're removing the signedness. absolute value of a vector, I'm sorry, the magnitude of a vector, you're not removing the signedness necessarily. Is that literally the same? Is that true? I would have to think about that for a second. That doesn't seem to be true to me. Magnitude can't be negative. That is true. You're right. So in that way, it's true. That's true. Because the direction would determine if it was negativeness. But yeah, length or distance or magnitude would not be negative. But are they still exactly conceptually the same? I feel like they're not exactly conceptually the same. I mean, if I walk backwards. But I get it. I understand that. Yes, I understand that part. The thing is, I guess, absolute value and magnitude to me are not the same. I guess I would have to really think about that. Because it's not just about removing the signedness. You're like, actually, you're like, right, but you see what I'm saying is like you're like absolute value. I mean, I'm not necessarily disagreeing like that maybe mechanically or at some level they're conceptually the same, but I don't they are like very functionally different. Like functionally different. In practice, they're really different. The thing I'm trying to accomplish when I use absolute value is extremely different from the thing I'm trying to accomplish when I'm trying to get the length of a vector. Like I don't think of them as the same thing. And getting the length of the vector isn't just about removing its signedness. It's about like extracting some piece of information from it, which maybe a math textbook would tell you that's the same thing. But to me, they're like different tools. You know what I mean? I just don't, I get it. I get the case you're making. I just don't agree with it. I think they're different. I think of them as different tools and I would use them in totally different contexts. And if I'm thinking about the magnitude of a vector, I'm not thinking at all like, and maybe I'm just wrong, but I'm not thinking of that operation at all as the same thing that I would be doing if I'm just trying to remove the signedness of an integer. And again, I agree with you that probably you can make the case that they are equivalent operations, but they're like, they're so functionally different. Yeah, but it's not. You're like, I don't even know. To me, you're like, it's almost like you're shifting domains when you're talking about, I have a vector and now I'm going to extract this totally separate piece of information from it that was contained into it, but it requires some gymnastics. Which, okay, I mean, and again, you could make the case to me that it is valid that they have the same symbols, but if I just am like I did 1 second ago, if I'm just going through an equation, and I will say, I'm pretty sure that equation we looked at the equation that we looked at that moment did not denote that the thing was a vector, right? Like you didn't just look at that, in the equation that we saw, wherever that was, math is fun, I don't think they marked that as a vector. So maybe they're the criminals here. Maybe maybe these people are the criminals because they did not put the little vector line on top of this. So when I saw this, I intuitively read this like, oh, that's the absolute value of A. Meaning A is an integer or whatever, is a real number. Not necessarily an integer, but it's a real number, and I'm going to remove its signedness. Nothing about this, if I had this totally out of any other context, would say to me that's a vector that I'm going to get the magnitude of. And maybe that's just the way they did it here, and maybe they don't know how to do the notation to put the cute little arrow on top or whatever. because when you look at Wikipedia, they have the little arrow on top, so it's very clear. And if that's the case, then that's fine. That makes more sense to me. It's like, okay, I get it. Otherwise, I don't like it. It's just confusing. Now I want to see like some math article. Oh, that's absolute magnitude. That's not what we want. I mean, I'm sure I'm going to read this and everybody's going to be right and I'm going to be wrong, but that still doesn't, in terms of the theory, but in terms of the practice, I feel like they're very different things. The main problem is I'm using DuckDuckGo. Is that the way you're thinking of it? Okay, that's interesting. I get it. Okay, so you're saying in every other case, anytime I'm looking at any other number, I should be thinking of that number as a one-dimensional vector? Is that true? Okay. Okay. I guess. Okay, if I'm going to just shift my world to view, shift my worldview that every number I see is actually a one-dimensional vector, then okay. I mean, I get, and I mean that the case you make there is reasonable if we're thinking about complex numbers. It's all magnitudes. Oh my god. So when I look at my bank account, it's a one-dimensional vector, the length of which is always just, even if my bank account says it's negative, it's okay, because the magnitude of that vector, which represents my balance in the bank account. So if I look at like my stake in Cloudflare at the moment, for example, I can feel okay about it because the magnitude of my position looks good. So great. This is good. This is really helping my investment, helping me feel better about my investments. Well, look at this. Actually, I feel like I have seen this before. Like the double lines. If you're talking about a position in space.
This all comes from an understanding that ideas aren't static, but fluid.
So this is magnitude, and we all know that Wikipedia is the arbiter of all things true. Or if not true, at least verifiable. It has the double lines here, which actually is ringing a bell. So I still say, intuitively, when I see this, around this, it is my assumption that it is a one-dimensional vector, and that all I have to care about is the signedness. And yeah, maybe it has a little vector sign on that, and that'll help me. Or if I see this, then I'm understanding, like, okay, we're talking about magnitude of a vector, and it's not just about dropping a sign. Okay, even here, a disadvantage of the second notation is that it can also be used to denote the absolute value of scalars and the determinants of matrices, which introduces an element of ambiguity. That's my point. That's what I'm here to say. No, I don't think you have a number of pipes that corresponds to the number of dimensions. I think it's just saying, like, hey, we're talking about points in space here. Let's put 2 bars so we're not just talking about a scalar, which is the number that that's the word I was looking for, I guess. Okay, but what happens if you get into like 10 dimensions? This is good. I'm sure somebody with a math degree is going to watch this and just want to punch me in the face, but this is my point. This is the point I'm making, which somebody felt the need to put on Wikipedia, so I feel validated that this is a bad notation if you are talking about magnitude. And of course, I mean, that's not even talking about the issues of matrices, although I think I feel like, yeah, where do you even use pipes like that in matrices? I guess here. But those are brackets. I don't even know, actually. I can't speak to that one. Oh, is that your strategy? You're going to exponential notation. So anyway, I feel like we're at least starting to get into the ballpark of where we want to be. Maybe we want to be in this ballpark. I don't know. I can't tell you exactly what ballpark I want to be in at any given time, or whatever metaphor I want to mix with. I'm actually not really seeing how that, whether this depth test is even doing anything. It doesn't. I mean, we got some chunkies in here. Is the depth test helping with the chunkies? Which I guess we don't want any depth, right? If we're going to be pure additive, we want to just draw everything, even though that's going to be a little more costly. So, a quick thing I want to try. I mean, honestly, this whole thing is moot because I never write things in mathematic notation. I would write things in pseudocode, I guess. And then there would be no ambiguity because my thing would say abs or mag. Although I feel like that is a thing where there is quite a bit of ambiguity from one language to another. Like, what is abs? What is mag? What is... I made these too dark, I guess. Also, this is not great. OpenGL uses length. Pretty sure processing uses mag. This bloom, it does not look how I want it to look, I will say. But part of that is going to be trying to tune the Fresnel and tune the colors and tune this fall off that I have based on radius. So I don't think it's hopeless. I mean, we don't have that same ethereal quality, or as much of that same ethereal quality as we had before. We still may want to add some secondary front to back gradient. What is this thing called? Lil GUI? I can't remember if Lil GUI lets you have colors. Lil GUI. Oh, could be an encoding thing. I don't see any gradation. I don't have any gradation here. Like banding, you mean? It could be the encode, but I don't... Banding does not appear to be a problem. I mean, I'm not saying this is how I want things to look. I think it's way too dense. We might want some like gradation to fade off in the back, which... what I would want to do, I guess, is like... I guess we need to like look up a proper Fresnel formula, because it's not just dot product. Usually there's a power and a bias and some other thing, so we would want to spend a little more time Notice to see if there's any blend modes that we prefer. I think additive is what I want though. Oh, this looks like a taffy machine. Turn on the back faces. 3 double side. So this might look crazy, but I think this might be more what we want. We would just have more tuning to do. Is that what it's called? What's it called? Backside? Side. Just side. So this lets us see the inside of the back, which is more appropriate. That's what we would have seen before. Oh, go back to sphere? Yes. I think it just would be a matter of animating the exponents down. When we do the proper lerping, I agree with that. I don't know exactly how I want... I know how I'd want to do that in Unity. I don't exactly know how I'd want to do that in 3. But let's do that next. And then I'm going to eat lunch. The only issue with that is there's some of these values that I don't like to interpolate. I don't like to interpolate these. Like this sweepy, I think it just doesn't animate well. It's very poppy. Just by kind of the nature of what how it is applied. But I think we can always animate the exponents. Although, now we have this stupid line. Where's that stupid line coming from? Is that me? Huh. Is that from the theta wrap? I thought I put it back. Oh, actually, well, shoot. I don't quite know what to do about that. That is a long theta. Which I thought we fixed that. Did we fix it? Or we tried to? So we basically have two ways to get to a sphere. Either either we have exponents, so it's basically this. Either the exponents are all 1 and those like coefficients are all 0, like this, but that's the one that would look worse to animate, or it's the opposite of that, where those coefficients are all 1 and the exponents are all 0. But that's the one where we end up with a stupid seam. I guess another way to think about it. Well, so the issue is there is no original sphere geo. This is the plane. So this sphere, there is no sphere. It just has to be, so it's either one or the other of these. The thing that is closest probably to just a straight up sphere would be I guess one way to do it, maybe this is actually the easiest way, is instead of trying to animate all of those, we just have a a weight that we pass. Let's try that. So let's say we have rather than trying to interpolate all these back, we will just lerp the weight. And pass the weight. And then in here, we'd have a uniform for weight. And then what we want to do here is have R is going to be equal to lerp R or 1 based on the weight. That seemed like a... I mean, I definitely broke this, right? Like, no question. What fun thing did I do wrong? Probably just the number 1. They're not called lerp, called mix. And you need to be... Oh, I didn't add that parameter. Where are you? Here. Okay. So now it's not about trying to interpolate those individual values. It's just us saying we want to go back. And maybe, you know, maybe we don't want to be that small. Maybe we want whatever radius we decide is our good default radius. I think technically 4 is correct, but let's do 2 so it's halfway, split the difference. So we can go all the way here, and then when we decide to do a transition, we can like go there. The only thing I don't like about this is when it is in perfect sphere mode, there is no there's no indication that it's moving. So what we'd probably want to do is maybe like put a little noise on a texture, very subtle, very, very subtle noise, just so that when we're in this mode, when we're in this like 0 weight mode. Oh, weight is backwards also. So we could do this, we can go up, and we can come back down, and we can wait. But I think I'd like just a little bit of like, you know, even the way this has a little bit of noise, just so you can tell it's moving. But we wouldn't want to go here because then we couldn't change these without also doing the thing. Well, the issue is if I go down here and I go down almost to 0 and have this, as soon as I start changing these values, you'll see a pop. Like, it will still be, there'll still be some visible pops, but it wouldn't be that hard to, we have good UVs, so just adding a slightly noisy texture would not be, just a texture to modulate the Fresnel might be nice anyway, just a little bit. What have I done? But it could be like this. It could go for a while, it'll transition between 2 states, and then when it's done, it would lerp back here, spin for a second, and then come back into its new state. And I mean, it really is, I don't know, like it really is, most of these I don't mind. Like I think this one animates well. And then the exponents all animate fine within a range, within whatever range we think is good. This one is okay. So both of these that are along phi are fine. Phi are fine. The ones that are along theta, like, are very poppy. Like, they just don't look very good. So I don't really ever want to be in a case where I'm lerping between two settings for M4 or M6. Otherwise, I would just never do this. Like, I would never care about going back here, because the only reason I'm really going back here is to hide those coefficients that get multiplied on theta, just because they don't look very good on theta. And another thing we should do while we're at it, since we're pretty dang close, is also make the super formula version. And I think this is light enough that it wouldn't matter. Like, we could just do them both in the same shader, and just lerp between the two results would probably be fine, because they actually share a lot in terms of, like, you know, the spherical to polar. The only place they actually differ would be here. This calculation of how what we're doing to kind of modulate whatever the radius. But let's get point-to-point lerping going, and not even worry about the lerp to 0 for now, because I just have to think about how I want to do that in Unity. So what we would want to say, sorry, how do I want to do that in Three.js? I did it in Unity. I just don't have a perfect sense of exactly how I'd want to do it here. So we want probably something like progress is equal to the clock not get elapsed. What are you doing? Clock dot get elapsed time mod 10 seconds divided by 10 seconds. That's not a good number. Is get elapsed time not in milliseconds? Maybe it's in seconds. Oops. Okay. So that would give us a progress, and then that would let us have like two values. It's a little annoying, right? Because we need to then have, this is never going to be equal to this. This is going to be equal to whatever the parameters are, but then we want like a target. How do you lerp? Does Three.js have a lerp? Vector 3 lerp, color lerp. Does JavaScript have a lerp? There's like a lerp function. I thought Three.js did. So there is a lerp for Vector 3. They're not just a Math utils. So is that in, do we have to do this stupid thing? We could just write it, but. Well, nay, or is it just in there? Do we just have it? Is it like 3.mathutils and we just have it and it's happy, or what's our situation? Why is M0 not changing? Did it yell at me? It yelled at me. But I would have expected M0 to be lerping towards... I mean, we could write our own lerp, I guess, right? Oops. No. Oh, wait. Right, the params wouldn't be changing. Am I crazy here? Wait, is this turning into a sphere? I can't tell. What did I do wrong? It's 10 seconds. Is this not right? Get elapsed time. What does this actually return? Wait, I don't need to do this, right? Can't I just... Okay, wait. This is not what I want to do. I just was not thinking. Is that what I meant to do? Yes, there we go. Okay. Blah. Okay. Not great. So, but, you know, we're doing the thing that I said I didn't want to do, which is interpolating that import M6. So that's part of why it looks stupid. We're also not randomizing our targets. Well, actually, let's keep that. Randomize these, but then what did I say? M4 and M6 we actually just don't want to change. Maybe. We can tune this, but I think it's kind of the idea. "10 seconds is way too fast, but it should just pop." Yeah. So then we want to say anytime that we, and I'm not doing the lerp to sphere because I don't know. I have to really think of how to do that in Three.js. In Unity, I would just have an animation curve that I would just independently animate the weight. Just have to think about the way I want to do that here. So, and then we want to say like, if progress is greater than or equal to 1. So every 10 seconds it should randomize. That sort of feels to me like that's not going to work, but let's see. And this will be, I mean, other than looking super weird, will be pretty close to what we had in Unity, I think. Doesn't seem like it's working.
Remember all the happy times we had? They're very much alike.
Is this a thing like where we never actually hit it? Like, do we never actually hit one? We just immediately... So what's our best bet for knowing when that wrap is going to happen?
They're very much alike.
I don't know really how to do it without more aggressively tracking like a start time and an end time.
I'll tell you the truth.
Which is okay, I guess. Because we have a reset we're going to run anyway, so when we reset, we can reset the start time. And it'd be nice if this worked, but... So if we had a let start time... So then this would be more like the normal way that I would do this, which would be start minus the start time divided by end time minus the start time, which of course is just the duration, and I know that, but it's just, I like to look at it this way. And then if we want to randomize and then reset the start time. Look at me wasting cycles. Seems okay. Then we'd want like a separate curve you know, like a separate animation curve. I don't know if Three.js has a concept of that. Like I want to yeah, I essentially want to describe a curve and then sample along that curve. That's an interpolator. But I don't know if this person just made something. I mean, I just want some keyframes on a curve. It doesn't need to be fancy. Keyframe track. That's all I want. A track of numeric keyframe values. And then, so if I can create some keyframes, can I then evaluate that? Interpolate linear. But presumably, I don't have to? Okay. I could interpolate smooth. But how do I get the, how do you evaluate this? What would you call that? I would call it evaluate. What would they call it? I want the thing that I put in the time. What am I missing here? How do you get the animation system article? I thought I was in there. How do you sample a keyframe track? I don't want to play it. I just want to sample it. I don't think I've ever done this in Three.js before. How to manually create animation clips for different keyframe tracks. Oh, you have to bind it to something? I don't want to do that. I just want to create one and then evaluate. I mean, there's other ways I could do this, but I do want to try to figure this out for some upcoming projects because it could be useful. The way I would expect it to work, and that doesn't mean that's the way it does work, but the way I would expect it to work is that you can create something. Yes, I could also do, well, Bezier would be a little more annoying. I mean, I guess maybe some other curve would be, you know, unless there's some auto Bezier. I'm definitely overthinking it, but I do have some projects coming up where it will be important to sequence things. But it looks like you have to, it looks like what it wants is to be bound to something and then to be played, is how it looks. I mean, you're probably right, but yeah, it's, I mean, for this is overkill. It seems like they have, oh, yeah, this isn't really what I would want. I would prefer, excuse me, this looks like it drives the property, like you tell it the property and it drives it and you have kind of no control over it. Yeah, but if we could do this, well, no, this isn't right. Is this, we want a path. Well, but I still can't get... How do you get the point on a curve? Oh, that's not really what I want. Catmull ROM, maybe. But I don't want three. I don't really want points in space. I mean, I don't know. I want, I mean, I really do want the animation thing. I guess I just have to find it and then update it. Do I have to have something that's going to play this? Wish there was better documentation. Or like... Like, do I have to connect this to a mixer and then have it play? I don't know the answer. So this seems like essentially what I want, but how do I play this is the thing. I have to, I see. Good grief. But I do have to have an animation mixture. This just seems overblown. If all I want is to have some representation, I mean, not that Unity's way is perfect, but I can just make an animation curve of whatever I want and then just sample, manually sample when I want to. Because I'm doing the interpolation myself, like... Which I guess I could just use a Catmull ROM and then just do it on one axis. But I don't want to draw it. I just want to evaluate along it. Can I not do that either? Okay, get point. So I wonder about the interpolation. I guess the interpolation is based on what class what you use. A line curve. And a line curve 3. Quadratic Bezier. Smooth 2D quadratic Bezier curve defined by a start point, end point, and a single control point. I don't want that. Interpolation's Catmull ROM. So I think a spline curve would maybe do the job. Still kind of weird. I mean, it's 2D. I still really only want one dimension, but whatever. Because it's a weight. I don't need other. But this maybe seems like the lowest friction way. It's kind of disappointing. I guess I could do... We don't even want a curve. I want a list of points, and then I want to interpolate between them with Catmull ROM. Feels like there should be a way to do that. See. Or actually, maybe this is what I want, right? And then one of these is time, and one of these is, if the way I'm thinking of it, one of them is time, and one of them is, excuse me. I don't really know. Like if you call inside the curve, if you call it get point. But what is this? You're passing it a t, but what is that? Is that actually sampling the x? Like if I do this? Okay, let's do a real dumb way, because I'm ready for lunch. So let's just say this very silly thing, that if progress is less than 10%, then we'll do this. Else, if progress is greater than 90%, we'll do this. Else, we'll do this. And the thing that's going to be the else is, in all other cases, the weight is going to be 1. Otherwise, if it's less than 10, progress times 10. So that's going to go from 0 up. So this should like fade us in. Unless I broke it. I broke it. Stop logging the progress, please. Less than 10. Do this thing. Do this thing. 0.1. Seem right? Excuse me. Okay, let this pop, and then we'll see if the... But I think I screwed something up. Okay. So that's pretty weird. Wonder why that didn't work. Excuse me. Because I shouldn't be changing this. I should be changing params. But now we should see params fade up, hopefully. Oops. Okay, so we saw that fade up. That fades up in the first 10%, which in this case is 1 second. So this will pop because we didn't do the inverse, but that's fine. So we have the fade in, and then the fade out would be it's greater than 90. There's 1 minus progress. Did I do it, or we need to invert that? One minus progress times 10. What? Oops. What'd I do? We said that progress is less than 1, then it should be progress times 10. In all other cases, weight should be 1. Come on, buddy. Should be less than or equal to. Progress is greater than or equal to. This still might be inverted. Let's see. Okay. There's no easing, any of that stuff that we would actually want, but we can figure that out. So let's set this to whatever we had it. I think it was 30 seconds previously. Well, let's just look at it for a minute and call it a day. So it's going to be very abrupt. I guess it's going to be 3 seconds down, 3 seconds up with no easing, which is not going to be very pretty. And there's no delay while it's in the sphere mode, but whatever. Actually, sorry, one more thing. The rotation's just too fast. So where do we do that? It's here. Too, even that's a little too fast. Yeah, no easing, not great, but oh well. Probably should make it like 15% or 25% or whatever. Yeah, I agree. That pop was never a very good solution, and your suggestion, even at the time, to do the transition was a good one. I think to make it really better, we just want to like ease down and ease out, which I would like to do with an animation curve. That would make more sense, but I just have to think about how I want to do that. So let's try it on the Kindle Fire. It was a little crunchy for some reason. Not terrible, but a little crunchy. You're not supposed to see my reflection there. Don't look at me. Weird, because it would appear to be mounted correctly, but okay. It's very glowy there. Yeah, there's actually some crunchiness I don't quite understand. We got 60 frames per second, which is good. Okay, let me try to focus that. Don't look at my nose. So cool in the dark. Oh, come on. Freaking. What? We can add some fancy touches. Nice clock, whatever. Colors need work. The glow continues to confound me. It almost looks like a DPI thing. I think that's a setting, used to be, like a setting you'd have to tell Three.js. The glow is really bumming me out. We just need to, I need to do the work. We can get there, I hope. Then we should go look back at the old one, because I like the colors of the old one and all of that, and we can just try to get back there. I don't actually mind it too much just sort of passing through the sphere. I was thinking it would go down to the sphere and change for a moment and then come back out, but it's kind of cool. And I also sort of still like the lava lamp version. You know, we don't have to always do the Purnell, so those could be some parameters too. So. Anyway, I think I'm done for the day. 2.5 hours. One more thing. The camera's just too far away. Moving the camera just a little bit. Two things. It's too slow. It's a little too slow. And I don't like where the camera's positioned. And one day we're going to go through this file and try to make it not a nightmare. Because it is just garbage on top of garbage on top of garbage. But where do I position the camera? What? Way down here for no reason. No reason at all. Okay. 7.5, let's say. And what? And 2.5, say. Okay, no more touching. Oh, a hole at the top. Got a tiny little bald spot. I don't even know what to say about that. Like, every time, whatever, it's just the worst. I don't want to go that way. We'll break it into some piles. Maybe we'll make a couple classes, whatever. Like, ES6 is fine. Like, once you get into... I don't know. Like, there's just so many of them, and so, every time I look, there's like some new version that I don't understand. It's such a weird thing, and it's such a web-specific thing of like, you know, whatever flavor of the week of like, oh, you still use this? Everybody uses this now. 1 week later, like nothing actually improves. Yeah, it's pretty close. I mean, like, some stuff is not so bad. The way the modules in Three.js were the most annoying part of this, and just whatever's broken in the latest version of 3. So I don't know. I'm not going to jump through a ton of hoops to like make this into a real web application. I do have a project coming up that will require that. I don't even remember the name of the thing that there was some other new build system that people seem to like with Three.js. And then there was that other one that we ended up using for, what's its face? For Cloudflare when we thought we needed a build system. And I don't remember what it's called. Like, I don't know. I do have there's a project coming up that's probably going to be maybe medium large WebGL project. I was thinking of maybe doing it in TypeScript. Like, if I had to have a dumb build system anyway, I might as well have type safety, was my thinking. Good luck to you. Godspeed. I mean, the modules part, I mean, well, yeah, there's plenty that makes that complicated. And when you deal with Webpack or whatever, it supports all of them. So it's like, oh, is this a ES6 module or a common JS module? Or, you know, there's just... I think this looks not terrible. I think the animation's really clunky. Like, those transitions are really clunky. But if there was just a little easing on those, which would not be hard to do, you just evaluate... Even with the dumb thing that we have right now that I have, where we're just sort of slicing up the interpolation, if we just put some easing on that, it would be tolerable. Thunk. It's actually not too terrible. The transition through doesn't need any ease, and even the ease out, I'm sorry, the ease in at the beginning doesn't really need it. Like, it can kind of just go 0 to 60. I didn't mind that much, but when it's coming up and then it just like clunks into place and there's no easing there, the ease out of the in the end, this right, like, that's okay. It's a little poppy and weird, but that I don't like, that little clunk. But this space avocado I do like. Okay, well, I'm glad we did the normals. That was definitely worth it. Thunk. Ugh, okay, I can't stand it. Let's just do it. Let's do it. Let's, just do the thing. Some like a cubic ease in out, maybe. We just throw this on everything. It's easy enough, right? Just steal this. Don't tell anybody. Don't tell anybody I just stole on the internet. This file's a mess. Okay, let's just put this in here. Oops. Get rid of the types. Definitely don't want any type safety in here. And then ease in out cubic on both of these. Not gonna do it. That was not good. Ow. What? Oh yeah, sure. So math after math and okay. Not perfect, but I think I would call it an improvement. And I think actually, I do want to do a little noise on it now that I think about it, just like a little grain. Because that was something we got sort of with that first one we did with the 4 million particles, it just ended up having this kind of like rich graininess, which I think was kind of cool. Ooh. Maybe we don't want to ease on the other side. Only problem. There's some things that just can't be lerped. Like if we wanted to have additive or not additive, that's fully like a state. Can't really do much about that. So that would be a thing that would have to toggle. Oh, the bloom's blowing out on this one, even though we're not at 100% strength. I might convince myself to just barely use any bloom and just add some secondary big... I don't know. I gotta think about it. A thing we could do, I guess, is write our own bloom, where we just like blur a thing and then add it on top. I don't know. I did years and years ago. I think I did write some effects composer effects for a project. I don't remember it being too hard. Like excuse me. Ideally, just run it through a few shaders, but I think there already is the pieces we want. I think already exist because we really just want to like blur, smash on top. I think this looks not bad, and it looks not offensive on the. I mean, it mostly looks okay. There's just maybe something about the resolution. So Three.js, mobile, DPI. I feel like there's a pixel multiplier or something like that you're supposed to manage manually. Set pixel ratio. Could also be the buffer size of our Okay, I'm gonna have to dig through this to really see what the idea is. Because there may be an inconsistency between the inconsistencies between the way the like screen buffer, I guess is a way to put it, just like the where we're rendering to versus the effects composer, which generally you would want that. I think generally you kind of want lower resolution. Okay, that helped. So that was even without even messing with the effects composer, unless they changed the effects composer internally. Looks kind of pretty. Although, you know, it did grow on me, the thing we had going in Unity. This guy? Nope, not this guy. I mean, that sphere kind of grew on me too. Uh-oh. What did I do? I moved the camera. Okay, let me discard all changes here. Oh, I must have saved. Aw, man. Oh no, maybe we're fine. We're fine. Man, there's something I like about this one. The lava lamp kind of grew on me, but we didn't quite get there in Three.js. Okay, friends. Kyle, Life is Yours, Binary, Draklin, anybody I'm forgetting? Thanks for stopping by. Maybe we'll stream. I think I'm gonna go on a hike tomorrow. I think I need to go outside. Maybe that's why I feel like I'm dying. I just haven't gone outside enough recently. So, can I look like I'm looking at this? Like, ooh, look. I should start doing like YouTube thumbnails like this, like this, like this. Like, you won't believe this, and then I'll put like a real clickbaity title, and the title will be like, "You won't believe what Life is Yours watched as a kid." I know. I can't do it. I can't do it. I don't have it in me. I'm glad you like it. I think we're getting there. I think we're getting there on this. I think there's some. It's a pretty thing. It's a satisfying thing to look at. Binaries transition suggestion is good. There's still some weird stuff with the geometry that I feel like I'm doing wrong, but I feel like we're approaching a point of diminishing returns on some of that. Anyway, make a face like this, and then put like Bitcoin. Put a blue outline around me, and I should be eating while I do it, like it's a mukbang. Is that the word? Is that the right word? I hope I shouldn't use an offensive word. That is it. Okay, I'm done. Okay, oh yeah! Look at all these NFTs. Ready? NFT, 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 bang, NFT, bang, 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 rich. $10,000, $20,000, $30,000, $40,000, $50,000. Ooh, the sphere is the best one though. The sphere is like, that one's next level. Is that still a thing people are doing? We have a pitch for a job for an NFT thing, and I don't know what to say about it. I mean, I don't even know what to say. I don't know what to say. Okay, should I try it? All right, Life is Yours. Send me 100,000 krona. Is that the word? You know what? Actually, I came up with this idea. Okay, no joke. While I was in grad school, I came up with an idea. Did I invent NFTs in grad school? Maybe I did. The idea was to have a company that produced things you could buy. Don't even worry about what the things are for a moment. But you were guaranteed that, and it was a physical object, but you were guaranteed that every single one was unique and that no one could get the same thing. And it was enforced by the software that it was a parameterized design system, and it was enforced by the software that no two people could get the same object. Did I just describe NFTs? I mean, and actually, speaking of like cross it with another, I wonder if I documented that project very well. I don't think I did, because I think the video was kind of embarrassing, but who knows? It was based on this project, this procedural frame project. Oh man, I blew it. So the idea, it came from these. That was these. I built this procedural laser cutter frame design tool for cell phones, so that you would. Where are the images? There they are. My thing's broken. We gotta fix that one day. But like, it would just do these procedural sort of Baroque frames. I know it was fun and cute. But then for another class, it was like a design for additions class. I must have not put it out. It was kind of dumb. But yeah, the idea was that you would procedurally, you could get them and you could make new ones by breeding them together. You could breed existing ones. You could just never get the same one twice. I mean, I still am not opposed to that as an idea. Like, what about that as an idea? Like, I start a business. I ordered a CNC router with my friend Sean, and you will get objects that are guaranteed, physical bespoke objects that are guaranteed to be unique, even though they're mass produced. That was kind of the pitch for the thing from grad school. I'm gonna eat Thai food and take a nap. Ugh. Oh no! The worst thing is in the course of these streams, I've showed all the code. I mean, a 250-bit string. I would. What's a good 250-bit string that I would like to own? I'll pay good money for that. Still get some chunkies right around the poles. Some parameters. I mean, whatever. We'll figure it out. I think we made good progress today. So the goal is, one, to do this little picture frame version. But, oh man, am I about to say the thing I'm about to? Yeah, I think I'm about to say this thing. I think we have to revisit the Unity version and do all the stuff to it too. So I think we want to try to keep them basically in parity, because I do want to make a Looking Glass version, and I think I have to do that with Unity. I don't think there's a Looking Glass WebGL plugin. Maybe there is. Maybe I'm wrong. Let's see. I think it's only HoloPlay Core SDK, cross-platform SDK that makes your existing 3D software compatible. Oh, check that out.
All right, let's bring that beat back.
Okay, so maybe, I mean, I'm only familiar with this one, but looks, I don't really understand how this could be true. How could this be true? Their products look so much nicer than than the one I have, but oh well. The one I have is pretty prototypey and costs more than the final product, but here we are. Okay, I am departing. Thanks everybody. Well, wrong button. Thanks everybody. Goodbye. Talk to you soon.